It's about to get real here, folks. We've got ourselves a quadratic divided by a cubic. Oh my goodness. First thing though, hey, we're going to factor. We're going to factor like champs, yo. Alrighty, so I'm going to have a GCF in the numerator, x, and then I'll have x plus 2 left over. In my denominator, I'm going to pull out an x, and then I'm also going to have to factor what would be left over, which would be a quadratic, right? So I'd have x and then x squared minus 4x minus 5. So what multiplies to negative 5 and adds to negative 4? That would be x minus 5 and x plus 1. Negative 5 and 1 multiplies to negative 5, adds to negative 4. We're good to go. Domain. First thing we're going to do, domain. Well, x cannot equal. Easy to see the 5 and the negative 1, but this guy right here, that x equals 0, if we were to set that factor equal to 0 and solve, it would be 0. We also need to avoid 0 for x. So 0, 5, and negative 1 would be our 3 domain restrictions. Woo! Woo! We got 3 there. That's what I'm talking about. All right, now, do we have any holes? Well, I can cancel out those x's. So yes, we have a hole at 0, comma something. Well, what is that something? Now that I have this fully canceled and all that stuff, let's rewrite it. X plus 2 over x minus 5, x plus 1. Okay, how do I get my coordinate, my y coordinate for that hole? I'm going to plug in 0 for x. So let's do that. So I would take 0 plus 2 divided by, and then it'll be 0 minus 5, 0 plus 1. So I'm going to have 2 divided by negative 5, which would just be negative 2/5. Cool. Not too bad when it's 0 that you're plugging in. All righty. Vertical asymptote. Let's go to the vertical asymptote. So what's left? Well, actually, I have 2 vertical asymptotes. X equals 5 and x equals negative 1 for this particular one. Awesome. How about my horizontal asymptote? Well, my horizontal asymptote is looking like, well, we got a small over large degree, so that'd be y equals 0. How about x-intercepts? Well, my x-intercepts are decided based on the what's left in the numerator, right? I got to set my function equal to 0, so it's going to be something, comma 0 for my x-intercept. So I'll take 0 equals, and I just need to focus on my numerator here because I got to get 0 divided by some number, right? I got to get 0 divided by some number. I don't want to be dividing by 0 because then it's undefined. So I'll take the x plus 2, and that would mean that x is going to equal negative 2. So it'd be negative 2, comma 0 for my x-intercept. How about y-intercept? Well, my y-intercept, if I plugged in 0 for x, I'm just going to get 0 for y. Or am I? If I plugged in 0 for x, wouldn't I get, wouldn't I get 0 over 0? Can I have that? Can I do that? I don't think I can do that. I cannot do that. Absolutely, I cannot do that. So what we're saying here is I would have 0 over 0, undefined, yo. None. Okay, no y-intercept on this one. All righty, we've got everything. It's time to graph. Let's do it. So let me get my vertical asymptotes first. Let's beef up that marker, right? And now let's get our vertical going here. So we've got 5, so that'd be this guy right here. And then I've got negative 1, which would be this one right here. Beautiful. Now my horizontal. Whoop. Oh, I thought I had it. I thought I had it perfect. There it is. All right. Y equals 0, right? Lovely. Now, how about holes? Let's see here. We said we have a hole at 0 and then negative 2/5. So that would be right, not on the x. We'd have 0, negative 2/5 would be right here. All right. And then let's see here. Do we have anything else? X-intercept, negative 2, comma 0. So negative 2, comma 0. Oops, that was at negative 3. I miscounted. There it is. There we go. So this is kind of an interesting situation that we have here. We have an x-intercept on our horizontal asymptote. Now, you can cross a horizontal or oblique asymptote. It does happen, and in this particular example, it does. So now we got to address what's going on here. Now, there's only really one section of this graph that I'm pretty certain of right now, and it's that middle section of the graph. So we're going to go ahead and graph that. There's a hole below that horizontal asymptote. We have no other x-intercept, so it can't cross anywhere else. So all we have that is going to be going on with this section is it's going to get close there. It's going to kind of come up, and then it'll come back down. So that's what's going on with that one, right? But that's all I know on that. I don't know what's going on to the left of my vertical asymptotes or to the right. So let's try and paint a better picture here. So with this one, what I'm going to do is on the left side there, I'm going to first pick a value that's really, really close to this asymptote. Okay, I'm going to pick something that's really, really close, and I'll do this section of the graph in pink since we already have that written down with our x-intercept. So if I'm going to pick a value that's really, really close there, it'd be negative 1.1. Negative 1.1 would be very close to that x equals negative 1, just on the left-hand side of it. So if I were to take my simplified form here and plug in negative 1.1 for all of my x's, oops, not 1.5, negative 1.1 minus 5, negative 1.1 plus 1. If I were to do that, is this going to give me a positive number, meaning that the graph is doing this kind of thing? Or is it going to give me a negative number, which means that the graph is pointing down? That'll help me start to paint the picture here. So if I do this, well, let's see here. My numerator is going to be positive, okay? The denominator, negative 1.1 minus 5, that's going to be a negative number. And then negative 1.1 plus 1, that's still going to be negative. So overall, I have a positive over a positive. Negative times negative is a negative. I don't know why I put negative 1. Sorry about that. So positive over positive is positive. This means that my graph is going up like that. Okay, let me get the little thicker marker here for the graph. So I know this is pointing up. And what's actually going to happen is it's going to come down here. It's going to go through this point and then come back up from the underside of that. It'll continue to get closer to that horizontal asymptote, but from the bottom part of it, right? Because it already crossed under and then it comes back up. It's never going to cross it again because I don't have any other x-intercepts, right? So it can't cross it a second time based on the information that we have here. So let's take a look actually at a table of values on our TI-84 graphing calculator, right? So I've gone and I plugged this into my y equals, okay? I went to my table set and I said, let's start this at actually negative 1 is where I initially started. And I'm going to have my change in table be 0.1. Now, when I look at my table here, I have an error at negative 1, right? I have a vertical asymptote at negative 1, so I should have an error there. Now, as I move to the left, so I'm going to have to go up here with my values, negative 1.1. As we said, it was positive, right? That's what it would actually be there. I didn't really care about the number. I just knew it was positive. And if I keep going here, well, at negative 2, we should see a change in sign. So it should be 0 there, right? We said that it's an x-intercept. Now my numbers become negative. But as you were to, if you were to continue going here, notice how they're going to be getting, well, eventually they'll be getting closer and closer to that 0 value. We're going to have to go for a while here. One sec. Why don't we go back to our table set? I'll say, hey, how about this? Let's go all the way to, how about negative 100? Okay, let's see what the values look like then. So if I do that, now I'll hit the table. You're going to see I got a couple zeros there, right? I'm getting closer and closer to that y equals 0 line the further I go to the left on this graph. All right. Now I got to figure out what's going on my right side of that vertical asymptote. These are definitely some of the most involved type problems. I'll do this section here in orange, I guess. I'm kind of running out of some colors here. So the process is going to be the same, except I'm going to pick a value to the right of this vertical asymptote of x equals 5. So how about 5.1? Right? So 5.1 would be just to the right of that vertical asymptote. So same thing as what I did here in the pink. I'm going to have 5.1 plus 2 over 5.1 minus 5 and 5.1 plus 1. All I'm really looking at is it positive or negative? Well, it'd be positive up here. The first one's going to be a positive, and then the second one, 5.1 plus 1, is going to also be positive. You don't necessarily have to write the this part out right here. If you can do it in your head, more power to you. But if I got 3 positives, that means it's overall going to be positive. So that means on my graph that I'm going to have, there we go. It's going to be going up here. And since I know I have no other x-intercepts, that means that I'm going to be doing this kind of thing. There we go. That is my final graph. Wow, that was a lot of work. That was a lot of work, right? This is probably one of Rihanna's favorite problems because she likes to do work. All right, I'm out.